This physics review video is from Unit 5, Projectile Motion. The topic is horizontally launched projectiles. Before we get to a problem, we need to talk about how the x and y dimensions are independent of each other. This is because the y direction has a force. And that force is gravity. So there is a force in this direction, which means there's also an acceleration. In the x direction, there are no forces. And no forces mean no acceleration. The only thing that ties them together is time. Time is the only link between them. So let's get to our problem. Here we have a red sphere. It's being shot off horizontally at 20 meters per second. It is 60 meters in the air, and we are ultimately trying to solve for the range. Well, first we're going to draw, what's the path going to look like? Okay, well, if I were to drop it straight down, it would go like this. If no gravity existed, it would go like this. But because it's accelerating downwards, it's going to match a combination of those two, and it's going to form a parabola. That's the actual path that it will follow. And where it hits the ground, that distance from here on the left, this is called the range. Okay, so in order to find that range, we have to take two steps. Step one is to find the time of flight. This is similar to the previous video, which is free fall. So to find the time of flight, we have to know our variables. V naught in the y direction is 0. Remember, it's going to the right, but it's not moving up or down. We also know that the acceleration in the y direction is negative 9.8 meters per second squared. Really, it's the total acceleration, since there is no acceleration in the x direction. I also know that the initial position is 60 meters, and that the final position is 0 meters. So using this information, I'm going to choose my equation. I'm going to use x equals 1/2 at squared plus v naught t plus x naught. Now I've got my equation picked out. I'm going to start to plug in the variables that I know. 0 meters equals 1/2 times negative 9.8 meters per second squared times t squared. And if you remember, our initial velocity in this case is still 0. So I'm going to put plus 0. And then I'm going to divide that, then add my initial position, which is 60 meters. I end up solving this. So the first thing I do is move the 60 meters to the other side. So I get negative 60 meters equals, the combination of these is negative 4.9 times t squared. Now I'm going to divide both sides by negative 4.9. Okay. My answer to that is 12.24 equals t squared. Once again, I'm not solving for t squared, I'm solving for t. So I have to take the square root of both sides. T equals 3.5 seconds. That's the amount of time that the sphere is in the air. Going back to my previous picture, if I know it's in the air for 3.5 seconds, and every second it travels 20 meters per second, I can now find how far it travels in the x direction. We also call this, again, the range. So the initial velocity in the x direction is 20 meters per second. It's in the air for 3.5 seconds. The acceleration in the x direction is 0. That's important. So now I'm trying to, again, find a position or distance. So x equals 1/2 at squared plus b naught t plus x naught. What happens is, if acceleration is 0, this is 0. It started at the cliff, so it didn't move anywhere. We're trying to now find x. So x equals 20 meters per second times 3.5 seconds. The sphere's range is 70 meters. So on my picture, I can now add that 70 meters onto my diagram. 70 meters. This is an example of a horizontally launched projectile problem.